Thank you. Right, now let's look at Concorde itself and the items that impressed me most. I was most impressed at the extent to which the mathematicians, engineers and scientists went to extract every ounce of performance out of Concorde. So let's start with the outer section of the wing. One of the things that they found is that they got the, not surprisingly, because they know very little going back to the early 60s about supersonic aerodynamics, the outer part of the wing section, that curvature was not quite right, and that leading edge of the wing was reshaped to reduce supersonic drag. Concorde, the secret of its success was that it was optimized out and out for supersonic cruise. The landing performance, the takeoff performance was of secondary importance. You had to extract as much range as possible. That seems to have been the goal. So that angle was reduced from the original 60 degrees to reduced by about 5 degrees to 55. Also, if you know that it flies well at supersonic speed, it does not mean that it flies well at low speeds. And one of the things is, don't worry too much about the detail, it's just trying to plot the flow patterns. But what you're trying to do is tilt the wing, that's the angle of attack, gradually, because Concorde, these wings are horrible at very low speeds. You have to come in at alarmingly high angles of attack. And the question is, will it still manage to generate adequate lift? So they were tested at different angles, up to about 31 degrees. And the thickness of the wing was adjusted accordingly. So it's a full-blown three-dimensional wing. The other thing is the leading edge of the inner part of the wing. The original shape was quite sharp and had a fair bit of a droop, but then they found that in certain conditions it generated undesirable flow field downstream, and this resulted in the engines struggling to breathe, caused engine surges. So that was changed, and that's the new shape. So it has less droop and it's also more rounded at the front end. Fuselage geometry. The slenderness ratio also turned out to be exceptionally important, and the fuselage was lengthened by about 3 meters, about 10 feet, and that was done by adding this extra bit of tail cone, which was missing from the earlier models, the prototypes. The other thing is the nose. At that time, when it started the Concorde project, there was no glass that could take the heat of about 100 Celsius temperature. And so the pilots, they were just given windows on the sides for taxiing purposes, but they could not see anything because that was not made out of glass. Of course, the pilots were not at all happy about this, and the end result was that they managed to provide them with a tiny window through which they could just about see, but of course the pilots were still not happy. So they changed the profile slightly to improve the field of view and also increase the window a little bit, and they were still not happy. So eventually they had to go for a tilting nose. So now you have a nose that tilts, but you still do not have the full glazing. Fortunately, by this time the glass manufacturers had perfected glass which could withstand high temperature, and they eventually ended up with the windscreens which we all see today with the tilting nose. So basically pilots won outright on this particular battle. The other thing that was picked up only at flight test, this was not picked up at the analytical stage or wind tunnel testing stage, is the fin. The leading edge, they found that it had to be sharpened a little bit, and furthermore the trailing edge of the rudder also had to be sharpened. There was no indication at the wind tunnel test stage or the analytical stage that this mattered a lot. Gentlemen, as a result of sharpening the trailing edge of the rudder as well as the elements and the leading edge of the fin, the fuel burn on a flight across the Atlantic was reduced by 900 kilograms, 9 passengers. That's the intake for Concorde. Everything looks neat, except have a look at this lower lip. I was shocked when I read about this. That particular lip plays a crucial part in angling the shock waves which were talked about earlier, what they found is that by slight tweaking, so when it entered service, this is what the lower lip looked like, but then they found that it could be improved, the performance could be improved by lowering the whole lip and also sharpening it. And believe it or not, this enabled them to reduce the fuel consumption on a transatlantic flight by 1.5 tons. That's 15 extra passengers. And what amazed me was that the mathematicians and the engineers and the scientists, they were willing to go that extra mile to gain that extra mile in range. That factor is missing from all the journal papers that I read. Now, okay, most of them are military stuff, and it's very difficult to extract information from Russian publications. But I must admit, I was most impressed with these exercises. The Olympus engine, Concorde's engine, that's the main engine, the intake and so on. Exactly as before, at low speeds, majority of the thrust comes, about 80% comes from the main engine itself. The intake hardly does anything. But when you go supersonic, about 3/4 of the thrust actually comes from the intake section. So that's the sort of compression that you're making use of. Just to give you the numbers, the compression there was only about 5, and the compression here was about 15, and the overall compression ratio worked out at about 75-80. But when you multiply the pressure difference by the surface area, which is what the force is, you find that the greater thrust actually comes from the intake section. And I thought I'll throw this in, because there must be people from Woodford here. This is a Olympus engine being tested for water ingestion. That's a water spray device, and they were conducting icing trials using this particular. I was very privileged to have met some of the people who were involved in these tests, including John Farley, who is now my boss in the Association of Aerospace Universities. And gentlemen, this is the final product. A very nice transverse camber, carefully designed, and she performed well for 3 decades, including the test flights. First, I think, maiden flight was in '69, and the first accident happened in 2001, I think, 2001. Right, let's have a look at the accident itself. What actually happened was there was a piece of debris from a piece of metal shed by another aircraft just before Concorde took off, hit one of the tires, the tire burst, and it hit the fuel tank just over here. And initially we thought it was the impact that had holed the wing tank, but we were wrong. What had actually happened was it had not punctured, it had not ruptured. The rupture actually occurred. Remember, it's at takeoff, so it sent a shock wave through the liquid, and the rupture occurred at the wall of the tank facing the wheel well. And so what you now have is a massive hemorrhaging of fluid, of kerosene, and it's mixing quite nicely, and you have an ideal mixture to ignite. Now, the end result was that all that flame was getting sucked into the engine, and the next thing you know, the engines start to fail one by one and so on. And this was the sort of, this just a simple figure to indicate how we did the analysis. I'm very thankful to Moji here for involving me in this. And also, just to make sure our calculations were correct, some tests were conducted by Health and Safety Laboratory. These guys are based up in the hills near Buxton, and they like to explode things over there. Anyway, it turned out that our results were in agreement with the test results that were measured, and the cure was to put in these Kevlar liners to try and prevent further occurrences of penetration of the fuel tank, either from foreign object from the outside, or try and minimize the damage caused by any internal shock waves within the liquid. At this stage, gentlemen, I have to say that I also spoke to some of the air accident investigators, including Ken Smart, who was the chief investigator at that time. There were all sorts of accusations that came about. The legal people got involved. What the magistrate has to do with an air accident investigation, I do not know. But there were other issues, such as there were some spaces missing in the the axle of the aircraft, and there were, if you look at the traces, for some inexplicable reason, Concorde actually began to, on that particular takeoff run, began to deviate from the center line, and apparently took out the runway edge lights and so on, and there were accusations that the pilots had not provided adequate steering action to bring her back in line. The reason it's veered off the center line was because of the spaces. Anyway, some of the comments became excessively anti-France, I thought, and I was a bit saddened with the way the whole thing spilled out into the public domain. And eventually the French court brought in some manslaughter charges against, I think, one or two people at Continental Airlines. Anyway, I'm delighted to say that a few weeks ago, an appeals court overturned the verdict, and as far as I'm concerned, the matter is over and done with. The program has finished. So, and the other good thing that seems to have happened as a result of all these unfortunate sequence of events is that the way the air accidents have been conducted involving Air France planes, I think has been done in a much more professional manner since. So let's look forward to that. Few questions I get asked. NASA used one of the Tupolev machines to conduct some supersonic trials. Why didn't they use Concorde? Back in the 90s, Concorde was being heavily used by both Air France and British Airways. So none of the aircraft were available, but I, as an academic, do wish that Concorde had been used for this purpose. In fact, it would have been a better platform for this because it could hold the supersonic speed for much longer. The other thing is, I've also been asked, could Concorde have replaced Blackbird on some of the missions? My answer is a resounding yes, it could. Some of the Americans believe that you had to fly 3 times the speed of sound at 80,000 feet to avoid getting shot down. I do not know of a single occurrence where a vehicle flying at supersonic speed was brought down by either a surface-to-air missile or an air-to-air missile in anger. In test flights, yes. Under controlled conditions, yes. But under realistic conditions, no. Of course, they have brought down U-2s and RB-57s and so on. But so I'll briefly have a look at it. Also, just to let you know, during Concorde test flights, supersonic test flights, to give Royal Air Force fighter pilots a bit of practice, the flight plan was provided, and the pilots stuck to the exact flight plan. Never once, apparently, did either the Lightning or the Phantom pilots ever manage to get into a firing position, despite knowing the exact coordinates at the exact time, which the Concorde flight crew stuck to. The other thing is, of course, will there be a replacement for Concorde? I don't think there will be, not for commercial travel, but maybe for private purposes. So let's have a look at items 2 and 3. What would I have done to make Concorde a military aircraft? First of all, would this exercise have been difficult? Of course it would have. There would have been a fair bit of studies to have conducted. The first thing I would have done, of course, is to get rid of all the seats and the galleys and all the toilets except one. I do need one for the pilots. I would also replace the weather radar with a ground imaging device, lots of cameras, electronic countermeasures, and remember, I have no more luggage, so I can put in additional fuel tanks. Those things are going to add something like 2.5 tons empty weight to the aircraft. But I have gained about 18 tons, but getting rid of the passengers, the seating, and the furnishings, and so on. And also, it's not really easy to install ejection seats in Concorde, but what you could have provided was a crew escape facility. And anyway, just remember, I got about an additional 14 tons of fuel to play with now. I do not want any tankers in sight. I do not want any special fuel. I'm going to stick to standard Jet A1 available at any international airport. I do not want 2 of the 3 air bases which Blackbird had to realize. Blackbird could only operate from 3 air bases around the world: Beale in California, RAF Mildenhall, and Okinawa. That's it. I don't want to make use of Beale or Mildenhall. Why? I'm only going to look at the missions conducted by Blackbird. Okinawa would have been adequate for me to conduct missions over Vietnam and the demilitarized zone over Korea. From the northern tip of Hokkaido, base called Wakanai, I can cover the whole of the Kamchatka Peninsula, including Petropavlovsk, where they have the nuclear testing facility, and indeed Vladivostok, where they have the submarine facility. From Tromsø or Narvik, I can easily cover the whole of Barents Sea. And remember, I'm right at the doorstep, which means sorry, but please forgive me, I'm not trying to be a warmonger, or I'm not taking sides here, I'm just looking at the operational mission specifications. There would have been very little time for the Russians at that time to react to these things. When a blackbird takes off from Mildenhall, it's not just the village, the whole county will know about it. It was unbelievably noisy. And if people in Murmansk get to know about it, they know that they're going to get hit within about an hour and a half, because blackbirds had to refuel, and that had to be done at subsonic speeds. So anyway, from Germany I can cover all the Baltic states, the Lithuania, Estonia, Poland, Latvia, East Germany, Czechoslovakia, Bulgaria, you name it. Remember, these going back to the 70s and the 80s, when these are all Eastern Bloc states. To conduct missions over Persian Gulf, I don't want to fly from Mildenhall. I want to forward base it at Akrotiri in Cyprus. It's right on the doorstep, and from there I can get access to Gulf, Red Sea, and Libya if necessary. And to cover Nicaragua, etc., I don't want to come all the way from Beale in California. I can forward base it at Miami and cover Cuba and so on. In fact, Cuba would be too close. I won't have the distance needed to get up to supersonic speeds. I'll probably have to station it further back, maybe somewhere, say, Pensacola in western Florida. Replacement of Concorde. Commercially, the answer, I was asked this question during the break. The answer is no, I don't think so, because no matter, even with the best of technologies, as you're about to find out, a Concorde, a supersonic replacement, will burn something like 3 times the fuel, at least 3 times, that an A380 will burn to transport one passenger 1 kilometer. And in these days of the green environmental issues, I don't think a commercial version will come about. However, you can have a version for the business tycoons. And this is one of the proposals recently patented by Grumman. I wouldn't ask you to invest money in it. They got a telescopic nose, swing wings, and so on. I think even Bill Gates will find it difficult to keep this thing, maintain this thing. I don't understand. Normally you do have telescopic needles and so on, but that is to position the shock cone. It's nothing to do with noise reduction as claimed in this particular case. I wish them the very best of luck, by the way. I would love to be proved wrong. But as things stand, I do not fully understand what's so brilliant about this particular design. This is just one of many. There's another one called the Sonic Star by a company called Ariane, I think. What would I do for a replacement for Concorde? The first thing, I'm sorry pilots, is that nose is not going to move anymore. You'd be horrified at the amount of space and weight it takes to get that nose to tilt. All the linkage mechanisms, these are weak points, the actuation systems, and so on. These days we got very good quality electro-optical devices onto which you can overlay digital terrain maps and so on. So I would go back to the fixed nose. The engines, there's a new generation whereby you can do a turbine bypass, and I certainly do not need reheat anymore. I do not need that extra 20%. I can get that by other simpler cycles. Also, I never liked engines grouped together, because quite often you find that if one engine goes, it will take its mate with it. And the other thing about spacing out the engines is that they can be used as auxiliary mass dampers to combat certain vibration problems. So space out the engines. Also, all the actuators on Concorde, all 8 of them, are outside the airframe with aerodynamic fairings. We now know how to package them inside those thin wings and thin fin. So that's the other thing. And of course, I'll also replace all the hydraulic actuators to control surface deflections with electrical ones. But for undercarriage retraction, I still need hydraulics. Those things are quite heavy. The wing platform will change. We now know a little bit more about the wave drag reduction mechanisms. Also, this distance I told you between the aerodynamic center and the gravity center, the smaller that distance, the the lesser the drag. It's called relaxed static stability, which is what Airbus uses in all its aircraft, and so do Boeing now. So I would go for that. And of course, there's none of this stuff about the engine controls being completely different to the aircraft control. They'll all be integrated under one roof. And also, thanks to developments in new generation materials, but I still stuck with the standard, the Jet A1 fuel, I can now get up to about 150 Celsius of baking, which equates to a slightly higher cruise Mach number of about Mach 2.2. So what does this mean? Well, put in all the numbers, what we think we can deliver is a 150 to 180 passenger aircraft with about 7 hours maximum duration. And if you are given the freedom, these are still air ranges, not with headwinds. You should, this with reserves by the way, you should be able to do Johannesburg to New York, San Francisco to Sydney, Sydney to Dubai, Sydney to Johannesburg, Heathrow to Rio, and Shanghai to New York. Now, I thought I was pretty good as coming up with these new fangled ideas until I came across this particular publication, and it turned out I was 15 years too late. Aerospatiale and the British Aerospace had actually done this. This was the future of Concorde study. The wing is becoming, the ogive is becoming more pronounced, engines are getting spaced out, and this was the problem at the stage at which they stopped the project. And I thought that was pretty impressive anyway, and getting all these things sorted out in 1989. Can I turn the clock back to the 1960s, please? Now remember, Lockheed had amassed a lot of data conducting supersonic flights on the Blackbird program. Ladies and gentlemen, this is what was proposed by Lockheed in 1966. This is a Mark II. How do I know this? From the nose cone, you can work these things out. Spaced out engines, no foreplane, no tailplane, single fin, and I don't know why, but the United States Congress rejected this particular design in favor of the Boeing one. Who knows, if they had selected this one in the 60s, Lockheed jetliners, supersonic jetliners would still be flying today. I don't know. This is an artist's impression of what it would have looked like, painted in Pan Am colors. And some strange facts. First of all, transatlantic passengers on Concorde clocked up more supersonic flying time than a fighter pilot would throughout his or her entire career. By the time the Concordes were retired, the two airlines which operated them had clocked up more supersonic operational experience than the whole of the world's air forces put together. Just to give you an idea how very, very intense the utilization was compared to the Air Force, that aircraft over there, GBOAC, clocked up 1/3 of the grand total flying hours clocked up by all Blackbird programs, from the maiden flight to the very first prototype to the very last delivery flight. And the numbers are something like, the flight hours on the Concorde over there is about 21,000 hours or something. The grand total Blackbird program is about 59,000 hours or less. Also, during the other thing people don't realize is that to conduct the supersonic acceleration, all other supersonic aircraft had to do a shallow dive. Otherwise, they were going to spend far too much fuel getting up to supersonic speed. Not Concorde. Concorde did at constant altitude. In fact, the passengers complained so much that they did not know when they were going supersonic. They installed Mach meters in the cabin to tell the passengers to brace themselves. And if they were kept quiet, they could just about feel a dull thud as it went through the sound barrier. And the best of all is over 30 years of test flying from 1969 to 2001, there wasn't a single casualty. Ladies and gentlemen, I would very much like to thank many, many people. As always, I'm deeply humbled by the knowledge that they hold. First of all, design development, Roger Chaplin at Airbus, John Farley, what can I say, Ted Talbot. John Stollery was ex-president of the Royal Aeronautical Society, loves to talk about supersonic aerodynamics. David Meyering, one of my gurus at Salford. Olga, well, Olga is from Moscow and translated a lot of the Russian technical stuff. fellow Concorde guides, Vince, Gordon, Ross, and John. Some of them are here. Many, many thanks, and the others as well. Some very good books. Stanley Hooker's book called Not Much of an Engineer. Please read it if you get a chance. One whole chapter is dedicated to the development of the Olympus engine. Collard's paper, Darling and Kenneth Owen's book is for the public, but it's fairly sort of technical. I would also like to thank Wikipedia, please. British Airways pilots. David Rowland was my boss when he was president of the Royal Aeronautical Society. Chris Oliver, one of the captains. Ricky Bastian, I met him at a meeting in Seattle. And Roger. Roger and David produced an outstanding video of Concorde operations. Overseas visits, I'd like to thank some TAS people, Peter Hampson, Tony Callan for visits to Moscow. Glenn and Peter played a crucial part in getting us along to the to see the JF-17 aircraft at one of the air shows in Turkey. John Wood, somewhere here, would like to thank him for taking us to Kiev, headquarters of Antonov. Craig Exeter, one of my ex-students who organized trips to Seattle, and Mark Lewis. Mark Lewis is ex-president of the American Institute of Aeronautics and Astronautics, and loves to talk about supersonics. He gave a brilliant lecture, and the title was Taking the Hype Out of Hypersonics. And Mike Level facilitated, and to that I should add the current chairman of the Seattle chapter, Pam Valdez. Air Accident Investigation would like to thank Moji, seated over here, my wife, for not only providing me with library material but also acting as my glamorous assistant today. Keith Moody, who helped out with testing of the failure of Concorde fuel tanks. Ken Smart at AAIB, Accident Branch, and John Britton and Jonathan Hallett at Airbus, who were the chief investigators. They came out to Salford University and to talk to our students and gave a very nice lecture. I'd also like to thank David and John for giving me a chance to come and talk to you today, and most importantly you for coming out in this horrible weather, in this cold winter's night. It's really appreciated. Thank you very much indeed. Ladies and gentlemen, what was so magical about Concorde is its unique achievement. Thank you very much.